Have you ever wondered how your computer figures out where to physically send data on your network, especially when all it has is the IP address of a device that it wants to send data to? That's where ARP comes in. ARP acts like a digital phone book, matching IP addresses to MAC addresses so your data gets to the right device. In this video, we're breaking down what ARP is, how it works behind the scenes, and why understanding it matters, especially when it comes to network troubleshooting and cybersecurity. Let's get into it. ARP stands for Address Resolution Protocol. It's a communication protocol used on local networks to map IP addresses, which are logical addresses, to MAC addresses, which is a physical address. In simpler terms, ARP answers the question, I know this device's IP address, but what is the MAC address so I can actually talk to it? Every time your device wants to communicate with another device on your local network, like a printer or file server, it needs that device's MAC address to send the data. And if it doesn't already know it, that's where ARP steps in. Here's a basic example of how ARP works. Let's say your computer wants to send data to your local printer. It already knows the printer's IP address, like 192.168.1.50, but not its MAC address. First, your computer checks its ARP cache to see if it's already learned the MAC address for that specific IP. This cache is temporary, and entries expire after a short period of time to make sure information stays up to date. And if it doesn't find a match in its ARP cache, it sends out something called an ARP request. This is a layer 2 broadcast message sent to every device on a local network segment that basically says, hey, who has the IP address 192.168.1.50? Tell me your MAC address. The printer receives this message and replies with something called an ARP reply, saying, hey, that's me, here's my MAC address. Your computer then stores that mapping in its ARP cache so it doesn't need to ask again for a little while. And now that it knows the MAC address, it can wrap that data in something called a frame and send it directly to the printer. This whole process happens in milliseconds, and you usually don't even notice it. ARP plays a huge role in how local networks operate, but it's also a target for attackers. Because ARP doesn't have built-in authentication, it's vulnerable to spoofing. A classic example is ARP poisoning, also known as ARP spoofing, where an attacker sends fake ARP responses to trick devices into sending traffic to the wrong MAC address. This lets the attacker intercept or modify the data in transit, a classic man-in-the-middle attack, but you can also see that referred to as adversary in the middle or attacker in the middle. It means the same thing. And that's why monitoring ARP tables and using security tools like dynamic ARP inspection and enterprise networks to determine the validity of these requests is important. So if you're working in cybersecurity, especially in network defense, understanding ARP isn't optional. It's foundational knowledge that helps you recognize and prevent these kinds of attacks. So that's what ARP is. It's the protocol that connects the dots between IP addresses and MAC addresses, so your data knows exactly where to go on a local network. It works silently in the background, but if something goes wrong or it's abused by attackers, it can quickly become a major issue. And that's why learning how ARP works is such a valuable skill for both network engineers and cybersecurity professionals. If you found this video helpful, give it a like, and please consider subscribing to the channel or checking out one of the other videos on screen. Thank you so much for watching, and I'll see you in the next one. Take care.